Think of a legacy mainframe as a massive, solid block of iron. It is heavy, rigid, and shaking under the pressure of modern demands. Inside the structure, the user interface, the business logic, and the database layers are physically fused together into a single, indivisible entity. Because these components are locked together, a sudden surge in user traffic does not isolate its stress to the interface. The load transfers directly through the entire system, straining the database and the core logic simultaneously. This creates a very severe deployment bottleneck. If a development team needs to make a minor update to the user interface layer, they are forced to recompile and test the entire massive application codebase. The problem with these systems is not strictly about speed. They trap critical business logic and data inside an architecture that cannot quickly adapt to new market requirements. When organizations realize they need to move away from these rigid structures, the immediate assumption is often that they must delete the old codebase and write an entirely new one from scratch. Application modernization is rarely a binary choice between keeping or destroying. It is a highly precise spectrum of structural interventions. This spectrum outlines 7 approaches. On the left, non-invasive techniques require minimal intervention. On the right, total system rebuilds. An enterprise architect uses this to diagnose technical debt and evaluate severity, matching it to the correct intervention. Successful modernization requires calculating exactly how to decouple the trapped layers of an application without bringing the business to a halt. Starting on the far left of the spectrum, we find the least invasive approach, encapsulation. Connections are established by building a transparent outer shell around the application, leaving the legacy code completely untouched. This shell acts as an API, allowing modern external applications to extract data from underlying legacy layers safely. By routing requests through the API, a business creates immediate interoperability with modern web services, avoiding the risk of breaking fragile, mission-critical core logic. Encapsulation operates as a tactical bridge. It buys an enterprise time to function in a modern digital ecosystem while deferring deeper, more complex structural surgery. Moving further along the spectrum, we reach interventions that target where the software runs, rather than how it is coded. These are recasting and replatforming. On the left is recasting, a lift-and-shift approach. Application components are taken from local servers and rehosted directly onto a cloud platform. The block itself remains exactly the same. Its internal functionality is completely spared from modification. Now compare this to replatforming on the right side of the screen. Replatforming shifts the application to a new runtime environment, but involves making minimal but necessary changes to the original code to ensure it functions correctly in that new space. Those minor code adjustments make implementing future system upgrades much easier and quicker to deploy compared to a pure lift and shift. Shifting the environment offers a fast path to cloud scalability, lowering physical server costs. However, it leaves inherently flawed internal logic perfectly intact. To address that flawed logic, we move to the next threshold of modernization, directly altering the internal code of the application itself. Refactoring on the left keeps the outer shell static, ensuring outside appearance and behavior remain unchanged. Inside, the tangled codebase rapidly rearranges into a clean, optimized layout to process inputs faster and clear technical debt without altering core functions. If the software needs to do more, an organization looks at re-engineering. This involves transferring the app to a new environment and actively deploying fresh technology stacks within it, swapping legacy databases for modern options like PostgreSQL or MongoDB. By integrating modern tools directly into the application's core, developers enhance overall productivity and build solutions that were strictly blocked by legacy constraints. These code-level interventions require a higher initial investment of time and resources. Because the old architecture is gone, developers can integrate advanced features that were impossible to support before. The final variation of this is restoration. This approach is reserved for extreme circumstances, undertaken only when the shortcomings of the current system critically threaten the survival of the business. Total rebuilds require the maximum amount of development time and carry the highest execution risk. They are the final option, trading that risk for absolute architectural freedom. Knowing the types of modernization is different from executing them. In practice, architects never tackle a monolithic system all at once.
The process begins with an analyze and prioritize phase. Teams examine the system to isolate specific legacy applications that deliver high value to the organization but carry the least amount of technical debt. Once identified, that single segment is precisely carved out of the massive monolithic block. This is app containerization. It means packaging a specific application, along with all the dependencies it needs to run, into a lightweight, isolated runtime environment, represented here by the glass box. By shifting the monolith into isolated microservices piece by piece, organizations can start with smaller initiatives. This phased approach builds stakeholder trust as they see individual components modernized successfully. Breaking down the monolith into microservices ensures the new system design is explicit and domain-driven. It forces the architecture to be based on clear rules, rather than the tangled, unwritten assumptions of the legacy code. Extracting microservices addresses the monolithic trap, but it introduces a new logistical problem: how to effectively manage a highly decentralized, fragmented system. The solution is a practice known as everything as code. Everything as code is the programmatic automation of the entire infrastructure, where servers, networks, and configurations are managed through code files rather than manual hardware adjustments. Managing the infrastructure programmatically allows teams to deploy changes automatically. This layers agility, resilience, and consistent security protocols across all development environments. Over this automated infrastructure, developers deploy continuous monitoring protocols and rigorous testing techniques. This ensures the application remains running smoothly with zero operational downtime while the transition occurs in the background. The journey moves an organization away from rigid, obscure legacy mainframes and into explicit, highly flexible cloud-native environments. What starts as a vibrating block of fused logic becomes a vast, decentralized network of independent nodes, routing data seamlessly and in perfect synchronization. Application modernization requires applying reverse engineering and highly targeted structural interventions. By decoupling the monolith, enterprises ensure their technology actively drives business growth rather than blocking it.